Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to my channel, welcome. I hope you'll enjoy this video and I might earn your subscription. What I'm going to be covering in today's episode is part 7 of my V-shaped guitar build. And specifically what I'll be covering is an overview of my cam process. Now this isn't going to be a step-by-step walkthrough of everything that's involved in this process, because a video like that would take hours and hours. It would have to be broken up over many episodes. I just want to give you kind of a brief overview. And another reason why I want to kind of keep it short and simple is because this is a process which is subject to change as technology evolves. As an example, I'm using MeshCam to set my tool paths and create G-code, but that process is likely going to change in the not too distant future because the software that I use to organize everything, X-Carve Pro, now has the ability to import STL files, and which means I can create all my G-code right there instead of using a separate program like MeshCam. However, I've got a few little details that I need to work through before I can make that switch. I need to build my 3D models a little bit differently. So once I have figured that out, then I'm going to be able to make that switch over to using X-Carve Pro. So let's stop yapping and jump on the computer, and I'll show you how the cam process is currently working for this particular guitar building project. What you see on the screen is the entire project file for this V-shaped guitar build. And this is done in X-Carve Pro, which is the online software solution that Inventables has available for their CNC machines. And I use it basically as a way to organize my projects, to establish many, not all, but many of the tool paths, feeds and speeds and all that sort of thing. And then I use it to send all that information to the CNC machine as I'm doing the cutting operations. If you look at the bottom of the page, you'll see a number of thumbnails running from left to right. And those are all the different project cutting operations that I have to perform to make the fretboard, the neck, and the body. Now I always make my fretboard first all the way to completion. Then I make the neck next all the way to completion. Then I bring those two parts together. Then I will finish by making the body. Now this is an order that I have been following for many years. And it goes all the way back 20 some years when I first started building guitars by hand using, my router and my bandsaw and drill press and all that. I found that by making the neck first, I could then use the neck to establish the shape and size of the pocket for the neck in the body. So I would always make the neck first. I also like to make, as I said before, the fretboard all the way to completion and the neck all the way to completion separately, and then bringing the two together. Because there were occasions when there might be a flaw in the wood, or maybe I made a mistake cutting a slot or something like that, and I would only lose that one part. I see a lot of guys who will glue a fretboard blank to a neck blank and then start to carve all the shapes and cut the slots, drill tuner holes and things like that. Well, if you do it that way and you make a mistake, even if it's just a small mistake, you've lost the entire two parts, both the fretboard and the neck. Whereas my approach, if you make a mistake, you've only lost that one part, either the fretboard or the neck, but not necessarily both. So you save time and money. Anyway, this is the whole project file. And there's a number of cutting operations that are involved in this whole thing. As you can see, as I kind of scroll through these different pages, And I've talked about a lot of this stuff before. And if you go to my YouTube channel homepage, you can type in key terms into the search window and find specific information about my CAM strategies, my CNC strategies, and all that kind of thing. I'm not going to get into detail here because it takes a tremendous amount of time. And like I said, I've talked about it before. But for this particular project, the first thing I'm going to do is I'm going to make the fretboard, and that's going to involve cutting the inlay pocket for my fretboard design. That's the first operation I'm going to do. And when I cut this file, what I'm doing is I'm just cutting a straight two-dimensional pocket into the fretboard blank so I can import an SVG file of this design. And this file was created in Adobe Illustrator. This is a top view, full-size, full-scale drawing of the fretboard. And I talked about creating this back in, I think it was part 3, so you can go back and watch that to see how I did all this stuff. But what I'll do is I'll isolate the inlay design, and that's going to create this file here. And I imported that into my Easel Pro, into this file here, and I'm going to cut that. And I've established my bit sizes, and I've got basically here 2 bit sizes. I've got a rough carving bit and then a detail bit. And then I have the specific feed and speeds on this page here, one for the roughing, one for the detail. And that's what's going to cut out that pocket. Then the next file is going to be the inlay material. And the first bit of inlay material is going to be this red acrylic. And it's actually a kind of a red pearl material that I'm going to be using. It's called Kieranite. And that's what I'm going to be cutting the roses and my 12th and 24th fret little thorns that I have here in this design. So then the next file is the stems for the roses. And this is going to be cut with a white pearl material. Now, because the fretboard is 22 inches in length, or roughly, the blank is 22 inches in length, and my material is only 9.5 inches in length, I have to divide the vines into 2 separate pieces. And because I want those pieces to be as complete as possible with no seams running across it that are visible, I've divided it right where one of the frets is going to be. So you won't be able to see where the split is because it's underneath a fret. Now, once I have created the pocket and then cut out the material from this from the acrylic that I'm going to be using, I will then glue the stems and the rose pieces into the inlay pocket. And I'll do this while my blank is still clamped down to the fretboard or to the wasteboard, because I don't want to lose my home position down at the bottom left corner of the blank. I want that to stay consistent with each of my cutting operations. That way everything is going to register nicely. And then once I have glued those pieces into the inlay pocket and the glue has had a chance to dry, I can then cut my radius. And the radius is created using a whole different process, because the other cutting operations that I just showed you for the inlay are 2-dimensional. They're cut straight down into the wood. There's no angles, there's no curved bevels or anything like that. They're straight down in. However, the radius is a curved surface, so I have to use a different strategy for cutting that. And what I will do is create a 3D model of the fretboard, which you see here. And I talked about this in episode 3 of this series. And I create this 3-dimensional file of the fretboard, which includes the radius. And then I'll save this as a .stl file. And then what I can do is import that into Meshcam to set up my cutting file for that 3D surface. And in truth, this is one of those strategies that it can change over time as technology evolves. And Easel Pro is a good example of how that technology can evolve, because Easel Pro now has the ability to import 3D STLs directly into Easel Pro so that I can set up my tool paths in Easel Pro and bypass having to use Meshcam. However, as you can see, I haven't actually done that yet, and that's only because I need to revamp the process that I follow for creating my STL files, because the files that I am now creating, they aren't importing correctly into Easel Pro. And it's not because Easel Pro is doing something wrong, it's because I'm doing something wrong when I create those STL files in Rhinoceros. So I need to go back in and just sort of work through that. But for the time being, I can continue to use Meshcam to generate those tool paths in G-code, and then I'll bring it into Easel Pro, which will send the G-code to my CNC machine to cut that radius. Once the radius is cut, while the blank is still clamped to the wasteboard, I will then switch back to a 2D cutting operation, which is to cut the slots for my frets, which you can see here. And I'm using a 0.024 inch diameter 2-flute spiral upcut bit to cut those slots. So don't ask in the comments what bit I use. That's the bit. And I use cut settings that I found work really well for that bit. It's 20 inch per minute feed rate, 10 inch per minute plunge rate. The depth per pass is 0.01 inches. The spindle speed is 20,000 RPM. And I just keep the offset. The fill method is the offset fill method. That's the default. I just leave it at that. It works just fine. And for the vertical ramp, I don't do a ramp into this cutting because I found it takes too long, or it really lengthens the time. And if I use just a straight down plunge, it works just fine with that very shallow depth of cut. So the time it takes to cut this is about 30 minutes. Now you can obviously cut fret slots a lot faster if you're using a table saw with a dedicated fret slotting blade. However, you have to cut the slots all the way through from one side of the fretboard through the other side. With CNC, you can stop short of the edge of the fretboard, thereby creating what's known as a blind fret slot. It's sort of like having a bound fretboard without having to go through all the trouble of cutting the or binding the fretboard with separate material. So it's just a really cool way to make fretboards. So that's basically how I cut the fret slots. And then once those fret slots are cut, the last cutting operation for the fretboard is to cut the perimeter shape. Now here you can see how the material changed. One thing I should mention about material is, in my situation right now, it doesn't matter what material I select when I'm setting up these files, because I'm doing almost all of my cut settings manually. I'm not using the automatic settings, so it doesn't really matter. And I typically will choose material just so I can see what's going on clearly. So what I have here is the perimeter cutting operation, and I'm choosing a strategy of cutting outside of the path's shape. If I were to cut on the shape, then the shape of the fretboard would end up being smaller by the radius of my cutting bit. And I don't want that, obviously, because then the fretboard is slightly too small. So I select cut on the outside of the path. That way the outer edge of the bit is running along the outer edge of the fretboard. So I end up with the correct size. I've made this mistake before where I have forgotten to change this and I've cut on the shape. And when I went to attach the fretboard to the neck, I discovered that the fretboard was just a tiny bit too small all the way around. So that's one of those critical things that you have to pay attention to. But once I have this shape done, I can then remove the blank from the wasteboard, cut the tabs, and liberate the fretboard from the blank and set it aside while I proceed with the next carving operations, which is to cut the neck. And that's going to involve cutting slots for my carbon fiber reinforcement rods. And you would think that that center slot is going to be for the truss rod, but it's not. There's not going to be a truss rod on this neck. I'll be talking more about that in a future episode. All I'm going to be doing is installing carbon fiber reinforcement rods. So you can see here the size of my blank here. This is 5 inches wide, 30 inches long, and 1.64 inches deep. And that's going to encompass the entire neck shaft and headstock. And speaking of headstocks, while I have the blank clamped down on this side, I will then cut the shape of my headstock, which you can kind of see here. And this is a G-code file that, once again, I created the model for the neck in Rhinoceros. And then I imported the STL file into Meshcam, and I set up a tool path for just the front of the headstock, which is what you see here. And there's two operations combined into one. The first is the roughing passes, which carve out most of the material. And then once that's done, then a finishing pass is done to give a nice smooth surface. Once this operation is done, I can then remove the blank from the wasteboard, flip it over, and carve the backside of the entire neck, which is what you see here. And again, this is two operations combined into one, with the hogging process of removing most of the material. And then once that's done, the finishing process continues and leaves a nice smooth surface. And you can see, if you look closely, there are some odd shapes down here at the bottom. That's where tabs are, because in order to carve this whole piece out safely, I need to have tabs which will connect the part to the blank, so that when I cut all the way through the wood, the blank doesn't go flying around as the CNC machine is trying to carve things. It's still going to be attached to the blank itself. And then once this carving operation has been complete, I can then remove the entire assembly, the blank and the neck, from the wasteboard. And then I'll use a small handsaw just to cut those tabs and thereby liberate the part from the blank. So that's just a safety precaution for both the user, the machine, and the part itself. After I've liberated the neck from the blank, I'll set the neck aside probably for about a week or so, because the act of carving a neck out of a blank can affect the wood's stability, and I want the wood to completely stabilize before I proceed on. So I'm just going to set it aside. But now what I can do is I can start working on cutting out the body. So the first file that I'm going to cut is going to be into the back side of the blank. So I will take my blank, which is shown in virtual on the right side of the screen, and I will clamp that down to my wasteboard. And then I'm going to use a 1/16 of an inch drill bit chucked into my CNC spindle, and I will begin the process of drilling some holes. And what these holes are for is the installation of the jack, the installation of the tremolo cavity cover, as well as the control cavity cover itself. So I have all those holes positioned here, and that's a pretty quick operation. It'll take about 6 minutes to drill all those holes. And then once that's done, I will move the spindle back to the start position, which is down in the lower left corner, and I'm going to swap out my bits. And the bit that I'm going to use is going to be used to cut the start for the cavities for the tremolo springs, the battery box, the control cavity, as well as the jack. And what I like to do is use a 1/4 inch diameter 2-flute spiral down cut bit for the start of this operation here. These are just shallow cuts, and what they're intended to do is to remove the wood at the start of those shapes, but to do so in such a way that it's not going to cause fuzzy edges or chip out. And that's what a down cut bit is going to do. But I'm not going to cut the full depth of those pockets just yet, because I don't want to do that with a down cut bit. I'd rather use an up cut bit because it cuts more efficiently and there's less of a chance of running into issues. So I'll just do a shallow cut for those pockets using that 1/4 inch diameter down cut bit. And then once that operation is complete, which is only going to take less than 10 minutes, the spindle is going to return to the start position over the lower left corner, and then I can swap out that down cut bit for the same diameter up cut bit. And then that's going to be used to cut the next operation, which is to complete the full depth of those pockets, which is what you can see here. And that's going to take roughly 20 minutes to cut those completely to their full depth, which is what you see right here. Once that's done, I have the cutting operations for the back of the blank finished. So what I can do is I can remove the blank, flip it over, and then reclamp it down to the wasteboard of my CNC machine so that I can begin the cutting operations for the front side. And that's going to involve a cutting operation which is similar to what you just saw on the back with the control cavity and the tremolo cavity and such. I'm going to be using a 1/4 inch diameter down cut bit to start those cuts so that I have a nice clean edge for all of those pockets. And that's going to include the neck pocket, the 2 pickup cavities, and the cavity for the recessed Floyd rose, as well as the holes for the switch and the volume and tone pots for the pickups. So I'll do that. And then once that's done, again, the spindle will return to that lower left corner, and then I can swap out to a 1/4 inch diameter upcut bit, which is what I'll use to cut the full depth of those pockets, which is what you see here. And that also includes the holes for mounting the tremolo, the Floyd Rose tremolo bridge. So I'll do that operation. And then once that's done, again, the spindle will return to that lower left corner. And I'm going to swap out for probably for this operation, I'm going to use it's going to be a 1/4 inch diameter upcut bit, just like I used on the pockets, but it's going to be a taller bit because I'm going to be cutting through the full thickness of that blank. So I need a longer reaching bit. But as you can see here, this isn't the same kind of file as what you saw here for these pockets. This is an imported G-code file. And what I did was I created a full-size, full-scale 3D model of the guitar body in Rhino. This is the body file that I created in Rhinoceros. And as you can see, it doesn't have any of the pockets. There's no pocket for the neck or the pickups or the tremolo, control, battery box, jack. None of those are included in this because they don't need to be. The reason I have to create this file is because I have a beveled edge around part of the perimeter of the body. And because it's beveled, that's a three-dimensional shape. So I have to do a three-dimensional carve. That means with my current workflow process, I need to export this as an STL file, and then I need to open that up into my Meshcam program, which is what you see here. This is the file imported into Meshcam, and those gray lines represent the stock size, the blank size. These red bars are tabs, which will prevent that part, the body, from flying out of the blank once the bit has cut all the way through from the top side down through the back side. It's going to hold it into the blank that's clamped to the wasteboard. Then I can cut those tabs later on to liberate the body from the blank. And then over here on the left side of the screen, you can see the different cutting operations that I've assigned to this. I have a rough cutting operation, which is going to remove most of the material. Then parallel finishes. One is following the X axis, the other will follow the Y axis, and that's going to produce a very smooth surface that is ready to be sanded with 220 grit sandpaper. So it makes the whole process work a lot faster. Then I have a pencil line finish, which is the final, it is a full depth cut that goes all the way around the perimeter just once, and that cleans up the edges to make them a lot smoother and reduces the tool marks left during the rough cutting operation and makes it a much smoother surface that again should be ready to be sanded with 220 grit sandpaper. So I'll show you kind of what the paths look like. So this is what those paths look like, and you can see them all. They're all represented all at once, and the green is the movement of the spindle for each one of those. So I'll turn off some of these so that you can kind of see what we're talking about here. This is the rough cutting operation, and the spindle will follow those green lines as it's cutting through the material. And the exact specifications are determined when I set these up. So this is what the rough cutting operation will look like. And then here's the first finishing pass, and it's going to be following the x-axis. And then once that's done, it's going to do a y-axis, which further cleans it up and makes it nice and smooth. And then once that's done, the pencil finish, which is just one pass all the way around to do one final little cleanup pass. So that's how that file, those G-code files are set up. And they're based on how I establish the tool path selections and feed rates, plunge rates, RPM, the step over, step down, all that kind of stuff is set up in these dialog boxes. And I do typically a much smaller step over for the finishing passes, usually 8 to 10%, so that I get a nice smooth surface. The finer it is, the longer that takes to do it. So that's how I create my tool paths. And then those are imported into my Easel Pro file, which is what you see here. And that's the rough cut. And I do those separately. I do the rough cut as one operation, and then I will do the finishing passes as a separate operation. And then when that's done, it's that pencil line finish. So they're saved out separately as individual G-code files. And then once that's done, I have one last file to cut in this project, and that is the control cavity cover. So I'll remove the body blank, cut the tabs, liberate the body, set that aside. Then I'll put my blank for the control cavity cover, which is 5 by 8 inches by an 1/8 inch thick. Grab a 1/16 inch 2-flute spiral up cut bit, and it's going to cut the perimeter shape as well as the holes for mounting, for the mounting screws once that's done. So that's how I have all my cutting operations organized within Easel Pro. All right, guys, well, there you have it. That is my process currently for how I am doing the cam side of building a guitar with a CNC machine. What I plan to talk about in the next episode, which I believe will be part 8, we're actually going to start cutting some wood, and we're going to start with the fretboard. And in truth, it's not wood like you would think. The fretboard I'm going to be using, the material I'll be using to make the fretboard, is Richlite. So that's a new product that I haven't used before, and I'm kind of excited to take a shot at that. So be sure to tune in for the next episode in this series. I hope that you've enjoyed this episode and will consider giving it a thumbs up. And again, if you're new to the channel, I hope I've earned your subscription. At any rate, until the next episode, take care, stay safe, and I hope you'll be back.